Well, hello everyone, and this is the video going over question 12. So, in question 12, they tell you the heat of formation of liquid water, and they give you this reaction. So this is the process of calculating enthalpy when you're given heat of formation values. And when that is the case, you take the heat of formation of the products and subtract it from the heat of formation of the reactants. Now, what's nice about this one is that, and what makes it nice, is we'll do the products first. So there are two waters, and they tell us that the heat of formation of liquid water is negative 285.8. Wonderful. Now, some of you might have been confused at this point that they didn't give you the heat of formation of H2 or O2, but the reason why they didn't is that you need to remember that the heat of formation of diatomics and single elements is 0. And then when you end up doing this math, you end up getting delta H is equal to negative 571.6 kilojoules per mole. And I would say on the test, most of us were able to do this for the most part. It was B that caused a lot of problems. Okay, so it says calculate the amount of heat that is released by the reaction when 20 grams of H2 is reacted with 32 grams of O2. So whenever they give you two reactants, the first thing you have to do is figure out which one is limiting. Which one is the limiting reactant? So to do that, we have to convert to moles. So for H2, there's 20 grams. And the molar mass of hydrogen, I believe, if I can do this correctly, is 2.016. They each weigh 1. So if we do a quick calculation here, that is 9.92 moles, about. Okay. And then for oxygen, this one's pretty easy. So there's 32 grams of oxygen. And oxygen as a diatomic, each one is 16. Remember, it's diatomic. So the molar mass of oxygen as a diatomic is 32 grams. And there's 1 mole. Now, normally, what we would do is we would divide by the coefficients, but it's pretty obvious that water is limiting, because we're going to divide this one by 2, and I don't know, you'll get somewhere around 4.5-ish, and you're going to divide this one by 1, or oxygen by 1 from the coefficient. So again, I'm getting these from the coefficients here, so 2 and 1. And then we get 1, so obviously you should have found out that O2 is limiting. So then you should do the rest of the work with O2. Okay, now we are struggling, and I actually look back at stuff from last year. We are struggling with thermostoichiometry. So let's read what B says. So it says, calculate the amount of heat released by the reaction when 20.0 grams of H2 is reacted with 32 grams of O2. This information we don't need, it's in excess. So we already know we have 1 mole of O2, because we did that calculation here. Now what is told to us, if we look at the equation, we calculated the delta H for this reaction. So that's the amount of heat released when you do this reaction. So what we do know is that for every 1 mole of O2, and how do we know it's 1 mole of O2? The coefficient here is 1. If this coefficient was 6, then it would be for 6 moles of O2. But we know for every 1 mole of O2, this amount of energy is released. And I forgot that number, 51.6. And this math turned out to be silly, because it's 1 times itself, which is this. And then it's kilojoules as our final answer. But the key for this was for you to do it with the limiting. Again, if you were doing this with if oxygen had a coefficient of 4, which it doesn't here, but let's say it did, it would be for every 4 moles of O2, you're releasing this amount of energy. But it's not. So if you got this question wrong, you should do question 12, that's the question that's labeled 12 on the makeup quiz question assignment.